You ever wonder what the most powerful, most violent events in the entire universe sound like? Well, the answer is probably not what you're thinking. In fact, it might just be the most shocking and the quietest thing you can imagine. So what would you actually hear if you had a front row seat to a cosmic cataclysm? Let's dive in.
Okay, so I want you to picture this. You've got a star, a real monster, way bigger than our sun. It's at the end of its life, and it just collapses in on itself, and then, boom, it erupts in a supernova. I mean, the energy this thing unleashes is almost impossible to comprehend. It's more than our own sun will produce in its entire 10 billion-year lifetime. So, if you were just floating there in your spaceship, watching this unbelievable cosmic fireworks show, what would you hear? Would it be this universe-shattering boom, a roar that shakes you to your core? Seriously, what sound pops into your head? Now, if you're a fan of sci-fi, I bet your brain immediately went to the movies, right? We've all grown up with these incredible space battles, just filled to the brim with the sounds of chaos and destruction.
You know the drill. Starships have that deep, powerful roar. Lasers make that classic pew-pew sound. And when an asteroid hits something, it's a massive, thunderous boom. It's all there for dramatic effect, of course. It makes space feel exciting and dangerous. But, as we're about to find out, it's completely made up.
So, let's just hit pause on Hollywood for a minute and get into the real science of it. Because the reality of what happens out there in the cosmos is honestly way weirder and more mind-bending than anything you'll see on a movie screen. Remember that star-destroying supernova we were just talking about? In reality, it happens in total, complete, absolute silence. Not a peep, not a whisper, nothing. And the reason for that all comes down to what sound actually is. Okay, so here's the most important thing to get your head around. Sound isn't some thing that flies through the air to your ears. Nope, it's a vibration. And here's the catch. That vibration needs something to travel through. It needs a medium. Like air or water, or even a solid object. If there's no medium, there's simply no sound. End of story.
Think of it like a chain reaction, or a set of dominoes. Here on Earth, when something makes a sound, say a bell rings, it vibrates. Those vibrations literally push the air molecules right next to it. Those molecules then bump into their neighbors, who bump into their neighbors, and on it goes. It's this wave of pressure that travels through the air, until it finally hits your eardrum. The air itself is the messenger.
And this is where the huge difference between Earth and space becomes so clear. Earth is full of those little messengers. The air is thick with particles just waiting to carry a sound wave. But space? Space is a near-perfect vacuum. The particles out there are so incredibly far apart that there's nothing for a vibration to grab onto, no one to pass the message to. No messengers, no message. So let's go back to that supernova. All that energy, more than our sun will ever produce, gets unleashed into the cosmos. It's one of the most powerful events imaginable, and yet, all that power has absolutely no way to make a sound. It's kind of like shouting into a void that just swallows the sound before it can even begin.
I love this quote from the source material because it just sums it up so perfectly. If you were an astronaut watching two galaxies collide, you would just see this incredible, silent light show. There'd be no boom, no shockwave hitting your ship, just silence.
So, okay, case closed, right? Space is totally silent. Well, hold on. This is where things get really cool, because scientists have actually figured out a way to listen to things that are technically unhearable.
Which begs the question, can we listen to space at all? I mean, you've probably heard those spooky sounds from NASA recordings of planets or black holes. If sound waves can't travel, what in the world are we actually hearing?
And here is the big secret, the key. Those recordings, they are not actual sounds. They're what you get when you translate data into a format our ears can understand.
The whole process is called data sonification. Think of scientists as cosmic composers. Their instruments out in space pick up all sorts of things we can't see or hear, like electromagnetic waves or fluctuations in plasma. Then, back on Earth, they take that stream of data and assign sounds to it. Maybe low radio frequencies become a low-pitched hum, and high frequencies become a high-pitched whistle. So when you hear it, you're not hearing the actual sound of space, you're hearing a beautiful, audible representation of the data. You're hearing the patterns of the universe sung back to you.
So we've busted the Hollywood myth, we've learned how we can kind of cheat to listen to space, but let's just take a moment to think about what this incredible vast silence really means.
Here on Earth, true silence is impossible. Go into the quietest room you can find, and you'll still hear your own heartbeat, the blood rushing in your ears. There's always some background noise. Our silence is just a lower volume. But the silence in space, that is absolute. It's a profound stillness, the total absence of sound itself.
And doesn't that make you think? I mean, the idea of a truly absolute, unending silence, it's a little unsettling, right? It's so completely alien to everything we experience. And yet, there's something incredibly powerful and peaceful about it, too. It speaks to the immense scale of everything.
And maybe that's the most powerful idea of all. The universe forges stars. It smashes galaxies together. It builds entire worlds. And it does the whole thing without making a single sound. Maybe its true power isn't in a loud explosion, but in its magnificent, majestic, and completely silent work.